Hi, thanks for watching this video, which is an update on my Oric high resolution sprite and rolling landscape test, which I'm doing with D flat, my custom language that I've built for the Oric 1. I've made a few small enhancements which I wanted to talk about, but also go a little bit into the code in terms of how it's done, especially on the sprite routine. So let's load the, before I go into all of that, I need to load the game. So I've already converted the source file that you see here on the left through the utility in the DOS prompt here, and so to create a tap file. So start loading the tap file. I'm going to speed up the emulator so that it can read this in much faster than it otherwise would in real time. And then now I'm back to normal speed. I'll start the emulator. You'll see some messages here, row 8, 9, 10, 11, 12. That's the sprite data it's processing, which I'll talk about in a minute. And now it's assembling 3 passes actually of the assembly code, generated the code, 646 bytes it says here, and press any key to start. Other enhancements that you can see here are not just the starry background, but I've added this kind of half moon, alien moon type landscape effect, and also you might notice the graphic of the spaceship is slightly different. So I'll press any key anyway to go and start this. So the first thing is that I've changed it from the red and the green landscape, which was quite garish, to I think this looks nicer, and also I've changed the way the ship moves. So now there's inertia and friction, so the ship doesn't just start and stop, but it accelerates from stationary and comes to a halt from motion, so simulating a little bit of physics essentially. And also when it gets to the edge of the game area, there's a bounce as well. It bounces off a virtual kind of wall, if you like, to stop the player from going off the edge of the game area. So that's the game. Not a game, it's a demo, but basically I want to turn this into a game. So that's where I've got so far, and I'll add other elements to this in future videos. But I wanted to quickly just talk about the sprite itself, how it's defined, and how we write that. Very high level, just explanation. So it's a 1 megahertz Oric. How do you write sprites to the screen quickly? Firstly, you'll need some sprite data. So here in the D flat source, you could probably just make out the ones and zeros of an image. The image is structured in a certain way, so the first 3 bytes of the sprite data are the width, the height, and the size of the sprite image. So the width is 4 bytes, the height is 12 rows, but the image is 5 times 12 in size, and the reason for that is that each row contains an attribute byte which will specify the color of that row before the row data comes. And now the other thing that you'll note is that each row of data, you don't see anything in the last 6 positions. So firstly, the Oric is 6 pixels per byte, not 8 pixels per byte like many systems. So I've got 4 times 6 pixels of data that I could put here, but I actually only use 3 times 6 pixels at the most. The reason for that is that the Oric would take a long time to shift this image to the right pixel position on the screen, and it wouldn't be very fast to draw at all. So what we do is we take this base data, and then for every row we create 5 more copies where the bits map is shifted to the right, and the Oric, the D flat routine here kind of does that. So you can see there's a loop. You read in the data, and then there's a loop that goes from position 0 to position 5, shifting each time and then writing that to the image data. So once you've done that, it's a simple routine then to copy this image data straight to the screen, rather than having to take the image data, shift it, and then write it. It would really take a long time, even in machine code, for a 1 megahertz Oric. So that's how the sprite is written. To simulate inertia, which I've done in another video, then you need essentially a velocity as well as a position which you and then when the velocity is not zero, you need to reduce it towards zero, basically, which stimulates friction, and that's what all the rest of this routine here does. But the main thing I wanted to talk about was the sprite routine, so hopefully that gives you an insight or an idea about how we can draw images to the screen and have a reasonably rapid draw sprite. Now it's not completely flicker free, even though it's done in machine code, because there is no vertical blank interrupt to time the writes to the screen on the Oric, not in software anyway. There are ways around it which I might try in a future video on real hardware, but for the moment this is about as nice as it's going to look. Hopefully that was something of use and gave you a bit of insight in terms of how you can draw sprites fast on an Oric.